Hello everybody, so in this video we will be looking at the LeetCode problem 45, that is jump game 2. So the problem statement states that we are given an array of positive integer nums and initially we are positioned at the first index of the array. Okay, each element in the array represents your maximum jump length at that position, and we have to reach the last index. Okay, we have to reach the last index in minimum number of jump, and we can also assume that we can always reach the last index. So what they are saying, if we have this array with index 0 1 2 3 4, and if we start from here, so they are saying that we have to reach the last index, and at each index, like at index 0 I have the value 2, it represents that how many jumps I can take 1 or 2 jumps. So if I take 1 jump I'll reach here, if I take 2 jumps I'll reach here, something like this. This is what given in the problem statement, and we have to return the minimum number of jumps a person should take to reach the last index. So since I have to reach the last index, I have to try all these. If I see I can start from here, I will start from here, I can go here and here, then from 3 I can jump and go here and here, or for 2 I can go there and there. So if I start from this index, I can take 2 jumps. In first jump I can go to this position, or in second jump, or if I take a jump of 2 I can go to this position, index 2. So if I take a jump of 1, I go to this position which is as index 1, and I have taken 1 jump, and I decide to take a jump of 2. So I'll just directly go to this position which is at index 2, and from index 3 I can take a jump to this position, to this position, or to this position. So if I go and take a jump of 1, I reach here. I can take a jump of 2, 2 3 1 1 4, I will reach here, and I can also take a jump of 3. So if I take a jump of 3, I'll directly reach the last index. So 2 3 1 1 4. Since in recursion we know that the only first the left side is evaluated, so all these will be evaluated later on. So we will go for this, and from here we can take a single jump only and we can go here. So if I take that single jump, I will go here at this position, and from this position also we can also take a single jump only, and I'll reach my last index, that is here. One step here, one step here, one step here. So if I go like this from 0 to 3, then to 1, then to 1, then to 4, if I take one step at a time, I will have to jump 4. Minimum jumps will be 4. Now if I am in this subtree, if I am at here, from here I'll just take single jump and I'll reach 4. So one jump, and one jump. I'll did a 3 jumps. Now I'll start from here, 2, I go to 3, 1 with 1 jump, and 3 I just directly go here with 1 jump. So it is getting a bit congested. So for this subtree I will jump twice and I'll reach there. So we can see that this condition is here also. So it is a overlapping sub problem, so we can definitely apply DP. But before that, let us just look at the recursive solution. So what will be the recursive solution if we are having something like this with index 0 1 2 3 4? What will be our base case? We have to reach this index, so our base case will be simply if my index equals to n minus 1, that is my base case, I'll simply return a 0. I don't have to go anywhere from here, right? This will be my base case, and then for each position at each index I have a choice. Like suppose at index 0 I have value 2, so I can either jump one step if I jump one step I'll go here, or either I can jump two step and I'll go here. For that I will use a for loop, and that for loop will start from the position I am at plus 1. I can go for a jump here and then here. So index, then my I is less than equal to, if I am at index 0, I can jump up to 0 plus 2, right? I can jump up to 0 plus 2. So I is less than equal to index plus the ARR of index. With this condition I also have to look at the condition. For example, suppose here I am having a 2. Let me just draw it here. Suppose I have something like this and I have to reach this position. If I reach at this position, from here I can jump here, I can jump here, I can jump here, but since my array is of size still here, my array is still here, I cannot go beyond my array. So I have to keep in mind, like, my I should not go beyond n. So there will be another condition that I is less than n and I plus plus. And for every index I will find a minimum and I'll add 1 every time I am calling the function again for my I, and in the end I'll return minimum. So this will be my recursive code. So if I draw it something like this, I'll start from 0, I can go to for 2 I can go to 0 plus 1, I can go to 0 plus 2. Now then there is a 3. For here I can go to 1 plus 1, but I cannot go beyond this. And similarly I have directly reached here, so I'll return the minimum for each. So minimum will be 0, from here minimum will be 1 and 1, so, and then answer will be 1, something like this. So for we will memoize this code. So for memoizing we will take a dp array of size n plus 1, and we will add just two statements: return dp of index equals to minimum value, and we will also check for a condition, like if my dp of index not equal to -1. If my dp of index is not equal to -1, I'll just simply return dp of index. So let me just code this. I hope it is clear. It is quite easy once you know how to do. So my n will be taking the size of the nums array, and I also need a vector array vector, and I'll name it as dp of size n plus 1, and I will initialize this array with -1. Now what I'll do, I'll store my answer in the variable answer, and I'll call the function. I will pass the index, starting index, that is 0, the size of the array nums. I'll pass nums as well as I'll pass dp, and in the end I'll return my answer. Now let me write the function. So in function, it is expecting a index, it is expecting a size integer variable, it is expecting a vector int nums. I'll pass it by reference, as well as the dp vector I'll also pass this as reference, vector int and dp. Now my base condition is, if my index equals to n minus 1, I'll return 0. My another condition was, if my dp of index is not equal to -1. This means, this is the where memoization comes in. It means I have already solved that problem, so I don't need to again call the recursive function. So it will just return the value at that index. So dp of index will be returned. Now I'll take a minimum value, which will I initialize to int max, and int x equals to nums of index. Now I'll run a for loop from index plus 1, I less than equal to index plus x, and index plus x, and I should always be less than n, I plus plus. Min value will always be equal to minimum of min value, and I'll add 1 and again call the function on I, passing n, nums and dp as it is. Here in the end I'll just return dp of index equals to min value. So that is the code. Now let me just run the code. Okay, vector. Okay, here. Now let me run the code again. So it is running fine. Let me just submit and see. Okay, we get a runtime error, int overflow. Okay, so what we can do is I'll just convert all this to a long int. So before I submitted, we got an error of integer overflow, so I just converted the return type of the function to long int, and here I'll and dp array of also long int, and in the end the solution is accepted. So the time complexity, if I discuss the time complexity for this question, so the time complexity will be big O of n, and there is another for loop we are running, so that will be big O of another. In the worst case, I have to traverse from here to the last, so it will be n. So the time complexity will be big O of n square, and the space complexity will be, I am using a dp array that is taking big O of n, as well as there will be a stack space of big O of n. Thank you for watching the video. We can also do this question in the tabulation form, but I've just shown it in the memoized version. So thank you for watching the video, and make sure to hit the subscribe button.